Hey guys, this is our last section of our probability unit about modeling randomness, 13.7. Okay, so this problem says a class of 25 students wants to choose 4 at random to bring food for a class party to be used in a platter shown. Any set of 4 students should have an equal chance of being chosen. What are some ways that the class could determine a random selection of 4 students? Okay, so the most obvious method I think for this would just be putting their names in a bowl and drawing them out, drawing 4 out. But there are also other ways that this could be determined as well. That would be random. Let's see. It says in this lesson you will learn ways to make random selection and use probabilities to make decisions and solve real-world problems. You can use probability to make choices and to help make decisions based on prior experience. A random event has no predetermined pattern or bias toward one outcome or another. You can use random number tables or randomly generated numbers using graphing calculators or computer software to help you make fair decisions. On page 895 in the textbook that you guys don't have, you will find a random number table to use with this lesson. Okay, but I have screenshotted it and put it on here. So this is what the random number table looks like. You have a bunch of numbers. Usually it will say something like use a random number table starting at row 12 or something like that. Okay, so then you'd count down to like row 12, which these are 2, 4, 5, 10, 11, 12. So then you'd start here. Okay, there are 28 students in a homeroom. 4 are chosen at random to represent the homeroom on a student committee. How can a random number table be used to fairly choose the students? Okay, so the first thing you need to do when you are setting up a simulation like this is you need to give each student a number, and you need to decide how many digits you need to use in these numbers. So if we're only using 1 digit, that limits our options to 10 options, 0 through 9. Well, we have 28 students here, so we're not going to be able to use just 1 digit. So this one needs to go out to 2 digits, which means we're using the numbers 0 to 99. And how you determine what student gets what number is up to you. I mean, I would just use the numbers 1 through 28, but you could really use any 28 numbers between 0 and 99. But let's just say that they're numbered 1 to 28. Okay. Then let's say it did say to use line 12 from the random number table. Then we would go down here to line 12, and what you would do is you look at the first 2-digit number, which is 52. Well, that doesn't line up with any of our students because ours are 1 through 28. So we're going to skip that one, go to the next 2-digit number, which is 06. So that's going to represent student 6. Okay, the next, even though there's a gap here, you're still going to put these 2 digits together. So 47 would be the next one, which is out of our range. Then 58, which is out of the range. Then 20. So we have number 6 and number 20, which work. Then 50 doesn't work, 99 doesn't work, 43, 10 would be the next one. Then 50 doesn't work, 67, 30, 41, 67, 30. I guess you guys can't see my mouse here. Okay, let me do this. Okay, so basically what I was saying is you look at the first 2 digits, so 52, that one doesn't work. 06 does work. And then 4 and 7, we're going to put those 2 together, but doesn't work. So right up here, 6 is the first one. 58 doesn't work. 20 does. Okay, then we go on. 50, 99, 43, 10 works. 50 doesn't work. 67, 30, 41, 67, 30, 29 is 1 too many. 37, 39, 67, 0, 0, which we didn't use a 0, 0 either. Okay, so then once you run out of numbers there, we just go to the next one. So then we go down here, and we do 0, 7, which will work, and that's it. I think we just wanted 4. So that's how you can use a random number table to do that. You just need to first determine how many digits you're looking at, and in our case it was 2. Say you had more than 100 though options, then you would need to go to 3 digits. But if you only have 6 or 7 options, you can just use 1 digit. Okay, so if we look at this one, a teacher wishes to choose 3 students from a class of 25 to raise the school's flag. What number should the teacher choose based on this line from a random number table? So again, there's 25 students, so we're going to have to use double digits, 2 digits. So first we look at 65. Doesn't work. And you always use the first 2 digits. You don't just start at 6 and then 5 and then 3. You always use 2 digits at a time. So 65 doesn't work, 35 doesn't work, 87, 04 is the first one. So student 4, 69, 87, 14 works. 98, 95, 09. That's it. We don't want 3. So those would be the 3 students that we would choose from this random number table. Okay. Making a simulation. A cereal company is having a promotion in which one of 6 different prizes is given away with each box. The prizes are equally and randomly distributed in the boxes of cereal. On average, how many boxes of cereal will a customer need to buy in order to get all 6 prizes? Okay. So what we're going to do on this one, to do this using a simulation, is I'm going to show you how to do this on your calculator first. So if you have a graphing calculator, this is how you can generate a random number. That way you don't have to have this weird table of numbers that you have to hold in your pocket. So let's see, come on. My calculator is right here. Okay, this is basically a TI-84. So what you're going to do is you're going to go down here to Math, this button that's below the y equals a couple rows. So you're going to go to Math, you're going to tab over to the probability list, and there's a bunch of different rand options here. If you just click rand here, that will give you a random decimal. Okay, in our case we're looking at numbers 1 through 6, so we want to use random integers. Okay, so rand int, you're going to push enter on that. For my lower bound, you can choose anything, but we just want numbers 1 through 6. So lower is 1, that's the lowest number, 6 is the highest number. This number n right here, this is just how many numbers it wants to generate. So we want to know how many it takes to get all 6 toys, I guess. So I just picked 20. I thought that probably should be enough. So if we paste that, enter. Also, if yours doesn't come up with that menu, you just need to type it in with the commas and the parentheses. So 1, 6, 20. This is your lower bound, upper bound, how many you want. So now I need to count up here, how long did it take to get all 6 unique numbers. So here's a 6, a 2, a 1, a 5, a 3. Now I just need the 4, which is here. So this gives us all 5 numbers here. 1, 2, 3, 4, 5, 6. So it took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 boxes on that first one. So what I'm going to do here is write down 13. I can't do it on here because then it won't let me use the calculator again. So I'm going to do 13. Okay, I'm going to do this 10 times and then just calculate the average of that. So if I do it again, I just push enter and notice the numbers change. So now I can just go up here and count. How long did it take to get all 6? There's a 1, a 5, a 6, a 4, a 2, and a 3. So I'm going to go count up to the 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one only took 10. Okay, now I'm going to do it again. And 1, I'm missing a 2. Okay, so the 2's not even on here, so I need to go over. Okay, it won't let me go over. Anyway, you would go over on yours, count how many it took to get to 2. I'm just going to say, well, it has to be more than 13. Well, let's assume it's maybe 15. You're not supposed to do that, but that's all I can see on here, so Okay, then we do it again. And again, this one doesn't have a 1. I need a bigger screen here. So that one will say 16 maybe. I'll do it again. This one doesn't have a 5. Okay, so it's not really working for me, but you would do that, 10 times or so, then calculate the average. That would be one way you could do the simulation. And the more times you do the simulation, the more accurate it's going to be. So if you do it 100 times or 1,000 times, it's going to get closer and closer to the actual probability, or the actual expected number, I guess, of boxes you need to buy. Yeah, sorry that didn't work out so well. Didn't know I wouldn't be able to scroll over. Okay, and then this brings us to expected value. So in problem 2, you figured out how many boxes of cereal on average you would expect to have to buy to collect all 6 prizes. You can use this information to make a decision about whether it's worth trying to get all 6 prizes if I have to buy 18 boxes. Similarly, you can use the expected value of a situation that involves uncertainty to make a decision. Expected value uses theoretical probability to tell you what you can expect in the long run. If you know what should happen mathematically, you can make better decisions in problem situations. The expected value is the sum of each outcome's value multiplied by its probability. Okay, so if A is an event that includes outcomes A1, A2, A3, and so on, and the value AN is a quantitative value, so a numerical value, associated with each outcome, the expected value is given by probability of A1 times the value of A1 plus probability of A2 times the value of A2 plus, and so on. Okay, so this is expected value. Looking at this one, it says, suppose you're at a carnival and are throwing darts at a board like the one on the right. There's an equally likely chance that your dart lands anywhere on the board. You receive 20 points if your dart lands in the white area, 10 points if it lands in the red area, and -5 if it lands in the blue area. There's an equally likely chance that it lands anywhere on the board. Oh, and then it gives us the areas. Okay. How many points can you expect to get given the areas for each region are white, 36 square inches, red, 108 square inches, blue, 432 square inches, and the total area is 576 square inches. Okay, so first let's look at the white. So it says you receive 20 points if it lands in the white. So that's our value times the probability it lands in white. Well, if we're doing the probability, we need to look at the area. So there's 36 square inches out of 576, which is the total. So that would be the probability there, times 20, plus, if it lands in the red, that would be 10 points, times 108 out of 576. And then the blue one is actually negative points, so we're going to subtract 5 times 432 out of 576. Okay, so I'm going to calculate this real quick. Alright, so I ended up getting a negative 0.97 for our expected value, approximately. So this game, basically, you are expected to get about negative 1 point on average, every turn. So, is it best to play this game? Well, probably not, unless you're just playing for fun. But you're probably going to lose in the long run. That's really the case with any type of casino game. The expected value is always going to be in the house's favor, is what they call it. So you're always going to have a negative expected value. Okay, let's look at this next part. How many points can you expect to get from the dartboard if you receive these points instead? Okay, so now this one is changing just the point values. So I'm not going to erase everything here. I'm just going to change this to the white would be 30 points, 15 for red instead of 10, and then negative 10 for blue. Okay, so basically they've doubled everything. So let's see if that doubles our expected value outcome. I don't know why I was thinking that this would double, but I guess I was just looking at this last one here. That one doubled. But anyway, this ended up being negative 3.5. So even though the two white and red areas increased, because the blue area is more negative, it's still going to be a negative expected value. Then part B, it says, for part A, what number of points could be set for the blue area that would result in an expected value of 0? An expected value of 0 would be considered a fair game because you're not expected to win or lose. So to do that, basically we need to take that circle 10 right here, make that a variable. So that would be, I don't know, you can call it x. And then you want it, all of that to equal 0, and then you can just solve that. So let's do that really quick. Let's see what I get. Okay, I think I was putting this as 475. That's really 432, or 472, not 4. Anyway, so I end up getting x equals negative 6.25, which means if, using this case right here, if the blue area is worth negative 6.25 points instead of negative 10 points, then it would be a fair game because your expected value would be 0. Okay, last one. Making decisions based on expected values. Okay, on the opening drive, a football coach must decide whether to kick a field goal or go for a touchdown. The probabilities for each choice based on his team's experience are shown on the page from his playbook at the rate. A field goal will give his team 3 points. His team will get 7 points if the touchdown is successful. Which play should he choose? Okay, so let's look at this. So we can calculate his expected points from taking a field goal. So for a field goal, he gets 3 points, and he makes them, or they make it 90% of the time. So his expected point value for a field goal is 2.7. And then for a touchdown, they get 7 points, but they only make it 35% of the time. 7 times 0.35 gives us 2.45. So he actually gets more points from a field goal, his expected points, because of the differences in the probabilities. Obviously, this is going to change on a situation, or situationally, because it's a game. So, but this does say on the opening drive, so this is like the first play of the game, I guess, or one of the first plays. I don't know. I don't really watch football. So, anyway, this would be your better option of these two. Okay, so even though a touchdown gives you more points, the field goal is going to generate more points based off your probabilities here. Okay, and that is it for Chapter 13 about probability. So make sure you guys do the Canvas quiz and Math Excel tomorrow, and I will catch y'all on the next one. Adios, amigos.